everybody. Oh, how does this part go away? Just gonna delete that. Ooh. Okay. Thought I was gonna delete something I wasn't supposed to. All right. So, I just want to give you guys a couple little updates. Let's see. Let me back up. Friday, you should have gotten something from the administration saying the new expectations and guidelines that we want you to follow. Starting this week, I'm going to start putting a bunch of stuff in the grade book. For the most part, you're going to get 2 grades. One is for checking in with me each week, and you can do that in a variety of ways. You can come into Zoom if you want to participate in the live lesson. You can just say hey, I'm here, I'm alive and well. I'll count that as a check-in. Or if you just want to send me an email, that's also a good check-in. So as long as you just touch base with me at least once a week, you get a satisfactory for checking in. The other grade is for the homework and such that you'll be getting each week. So you'll, for the most part, have 2 assignments each week, like normal. So you get a lesson on Monday and a lesson on Wednesday. So you'll have the whole week to do both of those assignments, and you'll get a grade for that. So it'll be like above expectations, meets expectations, below, or incomplete. So obviously, if you don't start it, it's incomplete. If you only do a little bit of it, it's below expectations. If you do everything, since they're going to be in Khan Academy or Delta Math for the most part, as long as you're working to reach mastery. So in Khan Academy, that would be like a 75% or higher. In Delta Math, similar fashion. Then you'll get my above expectations as long as you're, trying your best and reaching that mastery level that I want. So that is going to be what's coming down the pipeline, and I'll post that in Teams tonight. I'll make another doc in there that kind of lays all of that out. Did my 5K player stop working? Yes, it did. There we go. All right, so your homework tonight is in Khan Academy. There's 2 little practices that I'm going to want you to do and achieve mastery. So if you get only 1 question right out of the 4, you got to redo it to try and do a better job. And you can always join me on my office hours, and I can totally help you with those. Not a big deal. So any questions, or can I dive in? I know my stream's slightly delayed. Okay, so this is Unit 7, Lesson 3. If you didn't print it out, it's fine. I don't expect you to have a printer. You can just kind of take notes on the functions and such. So, okay, hit my microphone. So we have f of x. Oh, what? Red highlighter, ew. Okay. F of x equals x minus 1, the quantity squared, minus 4. So that's our original function. And I'm just going to go ahead and graph that right away. So based on the fact that that's our equation, our minimum, so state the min for each, is going to be the point 1, negative 4. Dive in. Thank you, Maya. So 1, negative 4 is going to be our equation for that. So go over 1, down 1, 2, 3, 4. Let's see, then it goes out a little bit. Sorry, gotta look at my calculator. Let's see, over. I'm using 2 screens. It just kind of keeps going up. Okay. So now I should label it f of x. All right, so a couple things happen here, and I'm going to do my best to color coordinate for you. So we have 2 different functions. It says g of x equals 2 times f of x. So what does that mean? So that means I'm going to have g of x equals 2 times the entire function of f of x. So 2 times that x minus 1 squared minus 4. And from here, I'm just going to distribute the 2. So we really get g of x equals 2 times x minus 1 squared minus 8. So if I wanted to state the minimum for that, g of x would have the minimum point of 1 comma negative 8. So we can see by multiplying the whole function by 2, we got much lower. And then we have another function defined here. We have h of x equals half f of x. So I'm going to do the similar process. I'm going to do 1/2 times the whole original function, f of x. So we get h of x equals 1 comma, oops, got a little bit ahead of myself there. H of x equals 1/2 x minus 1, the quantity squared, minus 2. So that means the minimum is going to be 1 comma negative 2. So it went a little bit higher. So let's graph all 3 of these and see what do they look like. I'm going to make my orange one a little bit more accurate. Not very happy with it. All right, let's put the roots on there. So root there, 1, 2, 3. 1, 2, 3. There's a root there. Okay, that's better now. So this is our original one in orange. And then what was next? G of x is going to be in green. So that one had a minimum of 1 negative 8. So 1, 2, 3, 4. I thought I changed colors. Come on, computer. And then I have, so my points are getting a little bit different. Now it's kind of getting, looks like a little bit skinnier. And it shares some points with the original function. That's kind of neat. So this is g of x. And then, let's see, I got pink for my next one. So pink we had, oops, 1, negative 2. We're a little bit halfway here. And then we still have some overlapping points. So there's our 3 functions. So orange was our original. The green one was when we multiplied it by 2. And the pink one was when we multiplied it by 1/2. So we can see that the shape of it changed, but they kept something in common. So they kept their roots. So the roots stayed the same, which is very interesting. That might help us in a little bit. So the roots stayed the same. Very interesting. So rules for dilating vertically. So that means, going longer or kind of squishing it. A vertical dilation only affects the y coordinate. For all functions, y equals k times f of x. So k above was either 2 or 1/2 that we ended up using. If k is greater than 0, then a vertical stretch has occurred. So if you're taking notes on scrap paper or in a notebook, this whole box is super duper important and you're going to want to write it down. So if k is greater than 0, then a vertical stretch has occurred. So like even if it's 1.1 or if it's 30, vertical stretch. So as we saw, it went stretching it out. And then if it was between 0 and 1, like we had 1/2, a vertical compression has occurred. So we kind of squished it in. So this box is important. So if you're taking notes, not on this actual real life paper, you're going to want to write all of that down. And if I'm going too fast, just let me know. I'll always pause and go back. It's not a big deal. Hiccups. All right. So if the point -312 lies on the graph of some function, f of x, which of the following must lie on 3f of x? So if it's 3f of x, to take some notes, we're going to have a vertical stretch. So it's going to get longer like that. And let's think about what happened up here. So up top, only the y coordinate was affected. So if you noticed, all of those x values stayed the same. It was 1, -4, 1, -8, 1, -2. So the x value is not changing. So if we're going based off that, I can do some elimination. That means 1 can't be it, and 4 can't be it. And then we're just really multiplying the 3 by the y value. So therefore, our answer is going to be choice 2, because 3 times 12 is 36. So x value stays the same. Y value changes. So very, very important with this lesson. For vertical stretching, that is. All right. Next it says, if the quadratic function g of x has a y-intercept of 0, 12, then what would the y-intercept of the following function be? So this one has more than one transformation happening. It says h of x is defined by 3 times g of x minus 5. So if I want to break that down, let's check this out. The 3g of x is multiplying by 3. And the minus 5 means then we are going to subtract 5. All right, so it has a y-intercept of 0, 12. So with 0 is going to stay the same because x stays the same. So we're really just going to be changing 12. What we're going to do to 12 is we're going to multiply it by 3 and then subtract 5 to get 31. So actually, it's really like we have the point 0, 31 if I want to be a little bit more precise. And that's it. No big deal. Just like doing PEMDAS, just a little functiony notation in there. All right. Next, it says the function h of x has a range given by the following interval from 2 to 10. The function f of x is defined by the following: 3/2 times h of x plus 8. So 3/2 is greater than 1, so we're still going to have that vertical stretch. So it says, what would the new range be? So what we're going to do is take 3/2, and we're going to start with the start of the interval, so times 2, and then we'll add 8. So this is multiply by 3/2, then add 8. So the reason I'm doing it to both these is, remember, range is both y values. Range means y values. So both of these are changing, so we want to know how long it's going. So that's going to give us a value of 11. And then we're going to do 3/2 times the ending part of the interval, which is 10, plus 8. And that's going to give us a value of 23. So therefore, my new range is 1123, which makes sense. It would have to be longer because we were stretching it, because it was bigger than 1. So this answer does indeed make sense. Okay. Doing okay so far? Okay. So we did vertical stretching. Now we're going to do horizontal stretching. So vertical was going this way, horizontal going outwards. All right. So we're given a function. F of x equals the absolute value, thank you, Maya, absolute value of x minus 2 minus 3. The quadratic functions g and h are defined by the following formulas. So notice, on the vertical stretching, the numbers were on the outside of the function notation. This time, the value's on the inside of the function notation. So it's a big difference from what we were doing before. So we have g of x equals f of 2 of x. So I'm going to kind of color coordinate again here like I was doing before. So g of x is therefore going to equal the absolute value of 2x minus 2 minus 3. So there's no distributing happening. We're just working on the inside, okay? And then, let me pick a different color. We have h of x is f times half x. Oops, wrong letter. So h of x is going to look like absolute value of half x minus 2 minus 3. Okay. So not just a little bit's changing with that x value. And we're just following the rules. We're just multiplying by what it told us to. So we are going to graph these, but let's state the minimums first. So for f of x, our minimum is 2, negative 3. For g of x, our minimum, oops, sorry, remove my keyboard. Oh, actually, no, let's graph it. I lied, like a Persian rug. Happy Monday. All right, so let's graph f of x. So we have 2, negative 3, oops, over 2, 1, 2, down 3. And then let's see. Let me just pull up my table of values here. So if you don't have a graphing calculator handy, which I'm not really sure where mine went, I'm just going to go to desmos.com/calculator. And there you can plug in pretty much any function you want. So x minus 2 minus 3. When you're typing in absolute value, you just need to type in abs and then in parentheses put what you want. All right, so let's see what pretty points I get here. So we have 1, 2, 3, negative 2. We have 1, negative 2. We have 4, negative 1. All right, this is pretty good. All right, want to make that nice and straight. Ah, look at that line. Fabulous. Okay, very good. So next I'm going to plug in the other two because it's not as easy to see what that minimum is going to be just by looking at the equation. So let me retype this. So we have g of x is equal to the absolute value of 2x minus 2 minus 3. All right, let's see what Desmos gives me. My computer froze. How sad is that? There we go. All right, let me make sure I keep my colors coordinated. So we're working with green. So it looks like we have a point of 1, negative 3. Excuse me. We have 2, negative 1. We have 0, negative 1. We get a couple more points in there. We got 3, 1. 1, 2, 3, 1. And we've got negative 1, 1. There we go. Go this way. Oh, if you're somebody, side note, who does own a printer, you can Google graph paper and you can print off like infinite amount of graph paper. If you're just, doing this on normal paper, just sketch it, it's all good. All right, so we could see it looks like it got a little bit skinnier, right? Looks like it got a little bit skinnier. All right, so we got one more. I need to change the blue. Oh, I didn't label. Shame. Shame, Mrs. Sadler. Label your lines. All right. Oh, so actually let's label that minimum point. We got 1, negative 3. Okay. So let's check out h of x. We have absolute value of half x minus 2. No, Desmos, don't click out on me. There we go. So let's see what points we've got here. We have 4, negative 3 is our min. 1, 2, 3, 4. 1, 2, 3. What else? Pretty point do we have? 6, negative 2. 1, 2, 3, 4, 5, 6. Negative 2, which means I have 2, negative 2. And this one, oops, bad line. This one got much wider. There we go. Awesome. So that was our h of x. Gotta love color coordinating. Very good. All right, so h of x has a minimum of 4, negative 3. Okay. So when we were doing the vertical, only the y was affected. So it makes sense that with horizontal, if we look at these points, only the x was affected. And that makes sense because vertical is going up and down. Well, what axis is that? That's the y-axis. And horizontal is x-axis. So that means we're changing, you know, skinnier to wider. So it makes sense that only the x would be affected here. So we've got another very important box right here. This box, if you're taking notes, old school style, this is the box you want. So only the x coordinate was affected. And we have a couple more words. It says if k is greater than 0, then a horizontal compression has occurred. So, and k is that number that we were multiplying by. So up top, when we had 2x, the green one, the compression was it got a little skinnier. And then when we had the fraction that was between 0 and 1, we had a horizontal stretch. So we stretched it wider. Stretched it wider. Stretched it wider. Because sometimes those two words can be a little bit confusing. All right. And let's see if we notice anything else, because having to type in your calculator and graph it is like, blah, I just want to find the min, right? So let's see if anything occurred. So our original for f of x was 2, negative 3. But for g of x, what happened to the x value? It went to 1. But here, it was 2. And then when we had f of half of x, our x value got bigger. So it's kind of doing the opposite of what you would think. Wrong color. Let's pick navy. So notice that what is being multiplied is opposite. So what that means is when we had f of 2 of x, our answer got smaller, not bigger. And we had f of half of x, our answer got bigger, not smaller. So with horizontal, it's a little bit opposite in what you would think of those numbers. So that is where I will leave you today. These two, the boxes that, you know, I highlighted, those are super duper important. So you need to go back and make sure you get those down. Very necessary. And your homework again tonight is going to be in Khan Academy. There's 2 of them that I would like you to strive for mastery. So make sure that you do that, and don't hesitate to come to my office hours Monday through Thursday 10 to 11 or Thursday from 1 to 2 as well. So have a fabulous day, and I will see you guys live again on Wednesday. Bye.